Namaste everyone, my name is Bhuvan and today I will be presenting my project assembly language program. So we'll focus on the four fundamental CPU and memory operations: swap, addition, subtraction and multiplication. So let me give the introduction. So to design and implement the assembly program of for fundamental CPU and memory operations to and analyze program efficiency in terms of instruction usage and memory access. And next one is to strengthen problem solving skill using low level programming constructions. So the main goal of this project was to get a practical hand on understanding of how microcontroller work at low level. So the first, what tools we are going to use in this? So we are using the Keli software, and this is a Keli software which is on the screen. So first we are performing the memory swap program. So this is a code for the memory swap program. So let me explain the step by step how we are going to uh, decode, means take the output from how they are going to swap. Let us run. So this is the memory address. So we are take from in the program we have mentioned that at 30h, that is the memory address. So from that memory address we are in that memory address we are changing the uh, uh, content, means address value. So we are changing, take the number as example like 15. So just consider as 15, and another value, we have for two numbers are required for the swapping. So in the place of 31 we'll name it as 50. So mm, we have given the two values 30 and 30 in the place of 30 and 31, 15 and 50. So now 30h moves A, and A will move to the or not, and at last R 31h will move to the A. So here the step 6 and 7, these two steps are very important. This will be swapping the store A's value from 31h into the address 30h. So to get the original 30h value back from or not, so this at last 31h, it is going to store the address of 31h. So now we'll run the program.
Hello, myself Deepak Tel. I am going to explain about the addition of two numbers using assembly level language. The goal here is to add the values at 32h and 33h and store the result in 34h. This code is simpler as much as we move the first number from 32h into the accumulator, and then we add the value 33h directly into the accumulator. Finally move the result into the accumulator. Finally move the result
32,
from the
33,
accumulator into
32, 33,
34h, and let
32,
us
33.
debug
No,
it.
no.
You will
31
go
ಇಲ್ಲ 32,
uh,
33.
you will go to the address 0 into 32.
32 ಗೆ
It will I will set our input to 10 and 32h and 20 at 33h.
10,
our
10.
target is our target is 34h is currently
Hmm.
empty. Now I will run it. and if you look at the address 34H, we see the result 30 is 30. The addition worked perfectly 34H, and then let's debug it. I will go to the address 0 into 30, 0 cross 32. I will 20 at you. Now I will run it. If we look at the address 34H, we see the result 30. The addition work is perfectly worked.
Now I am discussing about subtract content of 36H from 35H, store the result in 37H. Result is equal to 35H minus 36H, and the first line uh, we load the first number minute from 35H into A and store it in temporarily in R0 and load the second number subtracted from 36H into A and fourth step store it temporarily in R1 and move in the minute 35H back into A and clear the carry flag to make subtraction a simple subtract R1 36H from the accumulator. A is equal to A minus R1 and store the result from A into address 37H and the last line uh, halt minus loop forever to stop the program and now we run the program. First we start the debug session
And
and in this memory one in 34 we store value as 35 we store the value 20
in address
and in address
36
36
we store
we
value
store value
10
10 and
result is
our result is and our result is
show in the
show in the
37H
37H
uh,
and
our final
our
output is
final output is
stored in the 30
stored in the
address 37.
address 37.
The answer
The
is 10.
answer is 10.
Next
Thank
part
you.
will be
And next part
continued
will
by
be continued by
1 kV.
Bhuvan KV.
And next part
And
will be
next part
continued
will
by
be continued by
J.S.ROHITH.
J.S.ROHITH. And the last one is multiplication. In this multiplication, the 38H and the 39H stores 16-bit results, and the result is equal to 38H into 39H. It stores the result stores the multiplication result, and 3AH is equal to low byte, and 3BH is equal to high bit. Move A, comma 38H. It loads the first number from the 38H into accumulator and move B, comma 39H. It loads the second number from the 39H into B register, mul AB. It multiplies the A and B. Results high bit is now in the B, and the result low bit uh, is in now is now in A. Move A into the address 3AH. Move 3BH, comma B. It stores the high bit from the B into address 3BH and stop. And SJMP stops and also loop forever. It stops the program. This clicking debug and start or stop debug. In 38th memory address, we are storing 5, and in the 39th address, we are storing 10, and we get a result 50, and the result will be stored in the 3. Third memory address, we can get the result that is 50. Conclusion. We just seen all the four programs run successfully into the Kali simulation. This project was a great way to understand how we can use the CPU register and the memory addressing to perform these fundamental